seasons change. Our roads were lined with adventure, mountains in the way couldn't keep us from the sea. Here we stand, open arms. This is home where we are, ever strong in the world that we made. I still hear you in the breeze, see your shadow
Hello everyone. Okay, let's see if I can hear myself on YouTube and then we can get going. So question number 1 is, why am I so blue? I understand it's quite blue here, but not that blue, which means the drivers from my camera are acting up again, but we can easily fix that. Here we go. Yeah, a little bit more maybe. Perfect. So, hello everyone. Great. Well, I could say great seeing you, but that's not really true since I do not see you. Well, I see you on chat, so great seeing you. I guess officially welcome to another of my live streams. And we had a break a few weeks, which was partly expected because I had quite busy evenings due to the last couple of weeks. But last week was quite unexpected because I got a cold and I kind of lost my voice, and I will be coughing today quite a lot, so I apologize for that up front already. Sorry about that, I'm still kind of recovering. So yeah, today's topic is going to be a CTF task, something we didn't do for a couple of live streams now, and we should do it more often, I guess. But then again, I'm not playing a lot of CTFs recently, so there isn't always an opportunity for me to solve some CTF challenges. But actually, 2 weeks ago there were some opportunities which I'm going to talk about, so we can chat about CTF tasks today. Today's moderator is going to be KrzaQ. KrzaQ is both on YouTube and Discord and IRC. And if you have any questions for me, you actually need to ping KrzaQ. His nickname is right here. Yeah, here. And you need to write the question to KrzaQ so that he can pass it to me using Magic. We are actually using Magic to transport our thoughts, so the questions will go to me directly. Yeah, and I actually do not need this for today since we are not using voice chat for that. Anyway, so yeah, let's do some updates, and I guess around 15 minutes past I'm going to get started with things as usual, so until then I will keep you occupied with random notes and random news. Let's start with oh, this is KrzaQ's blog, and as you can see, it's the birthday, almost a birthday, we missed it by 2 days, of the post. This newest post is actually already 1 year old. This is a great thing to celebrate, I think, so proper digit separation in C++, happy birthday. But I guess also means, KrzaQ, you need to write more on your blog. Your content is awesome, please write more. This is the message you should be passing to KrzaQ on our chats. But the address of his blog is dev.krzaQ.cc. Then, most of you already know, since I've been spamming this like left, right and center, right, that I have a Discord server now. So if you want to join, just follow this invitation link. If you're using a Discord, that is a capital Q, then A, small w, small f, capital E, 5R. I guess I can actually copy paste this link to our YouTube chat, since on IRC it's already in the channel topic. So if you are on our IRC, then it's quite easy for you to get it. And actually the Discord link should be scrolling in the feed bar from time to time as well. Now, yeah, and there are actually like, I think over 100 people on our Discord online, and over 600 in total, I think. So the crowd is gathering there. As usual, the Polish channel is more active than the English one, but there were some chats on the English one as well. So yeah, you're invited to stay. And I'm actually quite easily reachable through Discord, since I'm checking messages, well, several times a day. Then, if you're following my blog, you did probably see this invitation to the Confidence conference in Poland. Confidence, that's a security conference, if you're wondering. So it's confidence as in security confidence, not like feeling confident, right? And it's again in the Polish Aviation Museum in Krakow, and it's in early June, 3rd to 4th. As written on my blog, I basically have a long history with this conference. It was my first large IT conference, which I went to in 2007. Well, as it's written. And then I played CTFs where I did talks, I organized CTFs, and now I'm a member of a program panel, which means I do selecting talks which appear on this conference. So I actually quite like it. And there are usually 3 tracks, above 1,000 people. Everything is, well, most of the things are in English. There are some talks in Polish, but most of the talks are in English as well. So yeah, it's pretty cool. I totally invite you if you're nearby to drop by, though you do need to buy a ticket, and there is a discount code on my blog as well for -20%. The earlier you buy the ticket, the cheaper it is actually. So if you bought it a month ago, it was probably cheaper than it's now, but there is still some time left before June. So yeah, there it is. Then, yeah, you probably heard about this idea of mine of creating an internet magazine, which would be for free. And the idea is that every article would be limited to only 1 page, though the author would have full control over the layout of that page, with some, with some limitations. For example, the font size couldn't be too small. So we're kind of finishing with the framework for everything. We have the logo chosen, and we already contracted a couple of graphic artists for the first cover. I'm finishing with the website, though I still need to pass it to a designer to actually tweak it a little bit. But I guess, hopefully soonish, I will start asking everyone to contribute articles if you could. Again, this is something like from community to community. It's a non-profit initiative, so we'll see how it goes. All the details will be on the pagedout.institute page, I guess, soon. As in, I wanted to start this already in March, but I guess that's going to be in a couple of weeks. Then you might have seen this tweet if you're following me on Twitter. I guess I'm just going to read it. Our security team at Google is hiring in Zurich, Sunnyvale, and Seattle, and we're looking for security specialists interested in security code reviews of both large complex systems and smaller applications. And this is like everything from the there is a lot of web, a lot of backend code for the web, and there is also like some low-level code beneath that, as low as it gets, basically down to the firmware level. So yeah, if you're interested, then send me an email. And we are basically looking for folks who already have some experience in security. We do not really have a junior position. We do have a new grad position, but yeah. So yeah, if you're interested, then let me know. It's, by the way, on site, as in remote work is not really possible. So if you would be looking to move into one of these locations and would like to try your luck with our interview process, which is quite long and quite complicated, but don't be scared, then just send me an email. Yeah. And this is for Google, for the information security engineering team, which is part of the wider Google security team. So moving to, I guess, more recent news, 2 weeks ago, or like 1.5 weeks ago, we went with Dragon Sector to Geneva to Insomniac, which is, again, one of our favorite offline CTFs. It's also, I think, the largest offline CTF, as in there is usually around like 400 people playing it, and split into up to 8 people teams. So quite a lot of folks were there this year as well. Yeah, as you can see, we didn't do too good. We finished on 3rd place, and yeah, I guess you might be like, hey, 3rd place isn't really that bad, man. But actually, this is the worst we ever did on Insomniac. Last year we were 2nd, and then we had a streak of 5 years in a row when we were 1st. So, but that being said, I'm quite happy with the 3rd place as well, especially that P4 was on the 2nd place. Well done, well played, and LCBC, which is an amazing team from Russia, took the win, rightfully deserved. So well played. And actually, like this CTF was Friday at night, and then at Saturday from 7 a.m. So a CTF finished on like 4 a.m. and from 7 a.m. I think there was another CTF, which was the OCTF, TCTF qualification round for the finals, which will happen, I think, in China later in the year. So we basically like took the team which was on site in Geneva, put everyone on a train, and went to this place, to my house, and played the OCTF from that location until a Monday morning with not a lot of sleep. So that's how I got my cold, actually. In the end, it actually went really good. If we look into, as you can see, we finally appeared in the ranking for the year. We actually won the qualification, which is quite interesting because when we solved the last tasks, we actually fell down to the 3rd place at some point, and then through the last basically half of the day, we didn't solve any tasks. But because how the dynamic scoring system works, the tasks which we had turned out to be worth more at the end of a CTF than the tasks that the top 2 teams had, which means less folks actually solved these tasks, which meant we gradually, like point by point, kept climbing until at the end of the CTF, we were on the 1st place with, I think, like 150 points of a spread. Well, not really, 50 points of spread, which is still quite interesting. And this is something which would not happen with the classical scoring system on CTFs, but since we, as the CTF scene, actually moved into the dynamic scoring, then this is something we need to account for happening on CTFs more and more, I guess. So dynamic scoring works like this, that what you see on the scoreboard is the current state, but what is actually important is the state from when the last task of the CTF is submitted, as in last task by the last team which submits anything, which basically means at the end of the CTF. So the scoreboard which is at the end of the CTF is the one which is the real one, and everything before that is an estimate. And the estimates are made using the formula that if a task is, for example, worth initially 500 points, or on the CTF it was 1000 points, and then that number, how much the task is worth, how many points it's worth, is actually decreased with like more folks who solve it, then that actually decreases the value of the task. Which means if like 100 teams solve the task, it ends up being worth like, let's say, 50 points. But if only 1 team solves it, it keeps being worth 1000 points. And if like 5 teams solve it, then it's around, let's say, 750 points. And it's not about getting that amount of points when you solve a task. It's about actually at the end of a CTF, that is when you should look how much the task is worth and sum everything up. And this is actually quite fair because previously the problem was that you couldn't really... It was hard for teams to say that, oh, we think this task is going to be hard and it's going to be worth 500 points. But in the end, like somebody finds like 20 teams find an easy solution for the task, which was unpredictable. And that means that a lot of teams got 500 points basically for, well, almost for free, while another task which was worth, for example, 100 points was only solved by 2 teams because it turned out to be really difficult. And because we now have dynamic scoring, that won't happen because the final score for every task will be automatically balanced due to the score being actually a derivative of how many teams did solve it in the end. So yeah, and this basically means that after like 2 days of playing, we were on the top first, but then teams still solved a couple of tasks and beat us to the first place. But because nobody solved anything else through the rest of the day until the CTF ended, and a lot of teams solved some tasks which we already have solved in the past, and the other top teams also. That means we kept climbing, but the other teams kept falling because we had tasks which were not solved by that many teams. I actually like the new dynamic scoring, and I'm not saying that only because, well, we won the CTF, but it's a system which is tested, has been tested on the scene through the last 2 years, I think, so it's working pretty well. I didn't actually solve too many tasks on the CTF. I only solved the Refrain, and I was working on Baby Sandbox, and I wasn't super close. I was still like 6 hours away from actually completing this one. It wasn't terribly complicated, but I was both already had a cold and was quite tired, so yeah. It was basically, the Baby Sandbox was a Lua interpreter, which you could execute bytecode, Lua bytecode basically, and then you had to go through a verification layer of the bytecode and through basically finding a bug inside Lua itself to get code execution in native code and yeah, get the flag that way. And we bypassed the verifier, and then I had some problems setting the heap up correctly to be able to finish the task, so yeah, didn't solve it in the end. Refrain, on the other hand, was solved by 10 teams, which is quite cool. It actually, we started looking at it with KD, or actually I should say that KD started looking at it in the train when we were traveling from Geneva to Zurich, and because I was sleeping on the train, yeah. So then we basically put our heads together how to solve it, and I finished it. It's a really unique and interesting task, so that's why I picked it for today and not any tasks from Insomniac. Insomniac, there were some really cool tasks as well. We might get to them at some point, but yeah, today I'm going to focus on Refrain. Yeah, so basically what you get is, I guess I'm going to give you this link. You're getting a perf.data.gz file, which is said to be taken from Ubuntu 16.4 plus LaTeX, or LaTeX, however you want to read it, which is, at the beginning, has been like a mystery. Why is it important? But while we were solving the challenge, it became apparent why specifying that it's LaTeX is actually important. So I'm going to give you the link to perf so you can download it. It's actually, I think it's only a couple of megabytes. Here you go. And I already have this downloaded. So I'm going to look if there are any questions, and if not, we're going to jump to the task. And again, I gave you the links on the chat, so you can download it if you want to tag along. Though it's going to be a little hard to follow every step I'm taking, because it does require some proper environment setup to be able to solve it. Okay, how do we do questions? Questions appear here. Yeah, okay, perfect. Did you attend Black Hat Asia 2019? No, I didn't. I never actually attended Black Hat Asia, so where is it done currently? Is it in Singapore? I would need to check though. I've heard there are I've heard that there were some interesting talks from folks who attended though. Have you heard about the attack on ASUS live update servers? Basically, compromised servers were pushing backdoors to ASUS laptops. Yeah, I did hear about it, and I started checking my hardware if I have any ASUS laptops. I do remember having one in the past, but it turned out it's fine. And I started checking my motherboards, because I also have a couple of computers with ASUS motherboards, but I have Linux on all of them, which thankfully, well, means I do not have the ASUS updates running. It's actually, yeah, quite unfortunate that it happened, though it's something like a type of an attack which is commonly speculated and has been speculated on the security scene for a long while, that the update servers might be used for something like that, for pushing malicious software. And this is also one of the arguments against doing fast updates and, you know, applying updates when they come out, because on one hand, yeah, they are fixing like the vulnerabilities, the one days which are known on the web, right? But on the other hand, you do not really know what you are applying, and nobody really had time to look at it. On the other hand, the question is anyone actually looking at it? Because that's not always obvious, right? So, interesting. Did I play Sekiro? I didn't. I know what it is, but I didn't play it. I'm currently playing mostly Apex Legends. Actually quite fun. What do you think about the fact that many companies do decrypt SSL traffic between their computers and the global internet to spy on employees? It's not really, I wouldn't really use the term spy in this case because there are technical reasons why you want to do that. One of the easiest ones being just to cache files which you serve, therefore they would be, served from your local servers and kinda like ease up on the outbound traffic, or actually inbound traffic, which is being used. Another is just to basically scan what is incoming to apply antiviruses and other stuff. There are several other reasons why one would want to do it. I'm not a fan of that actually, because it leaves a couple of problems. Like, for example, if you check the certificates in a correct way on the place where you are decrypting the traffic, that's fine. If you, however, for example, don't revoke a certificate which became untrusted, then all your users in your company are actually affected by that. Where in case somebody would not apply an update or something, only they would be affected. So yeah, there are pros and cons, and I understand why some companies do it. I'm not a fan of it. On the other hand, this is something also that, well, you might also want to trust more your network than you trust the outside world. I'm more personally a fan of end-to-end encryption, but yeah. Again, sometimes there are reasons for that. Will there be some new challenges soon? I guess you're asking about the missions. No, not the missions. However, there will be a couple of challenges on my blog with rewards in the form of tickets to the confidence conference I mentioned. They should appear in a few weeks. I'm not really sure when. I just need to make the challenges for that. In which year have you started security stuff and hacking? That's a good question. I'm going to say 2004, and I'm probably wrong by a couple of years, one way or the other. Depending on how serious you're asking. Like, when did my professional career start? Then that was more about 2005-ish, but yeah. And programming a long time ago. A really long time ago. What do you think about people thinking we live in a simulation? That's actually I guess you're referring to the talk that I think GeoHot gave on a conference some time ago, like recently. But that's a pretty old hypothesis. So yeah, it's interesting. I mean, as a scientist, I'm not going out to outright say, no, that is not possible, because it has not been proven that is not possible. I've read a little bit about it, and there are some experiments which are proposed that if we actually try them out, then they should give us a definite answer. I don't think that's the case, but again, as a scientist, I cannot rule it out. Yeah, that's what I think. It's an interesting hypothesis. So, one, easily explainable by the fear of death, as usual. How much do you spend throughout the day in learning about computers? Well, I guess I'm either not doing anything related to computers, or I'm applying my skill, which I know, which also means I'm learning new stuff on the way, or I'm just learning new stuff. So a lot of the time, I would say. Like, more than it's like this. In programming and like in any deep IT area itself, regardless if it's security programming or like sysops or whatever, then you will spend a lot of time learning, and there will never be a stop to the learning. So, and that's fine. I actually enjoy learning. That's the thing I most enjoy about IT, I guess, is learning new things. Yeah. But there will never be a moment where you say, oh, I know everything now, and from now is like all my career I will just use my knowledge. It's just everything is evolving just way too fast for that to be true. Cool. So I guess we can start with the CTF task, since I guess we reached out the end of the questions. Again, if you have questions, then do message this guy, KrzaQ, because he actually looks at the chat and pastes me the questions. Cool. So I already gave you the, well, talked about the task a little. I did say that we are getting a perf file, which is actually compressed. So let me quickly decompress the perf file. And if you ever use the perf tool, you might know what that is. Otherwise, you will not know what it is. So let's see in everyone's favorite tool, which is a general file viewer. As you can see, it's some perf file, and there are some, I guess, like name of Linux kernel modules, but if we scroll down, we will find also name of userland libraries, and then there is a lot of binary data, and if we scroll at the very bottom, there is another set of things which looks like text stuff, and there's also, for example, this image magic, something, coder, whatever, which kind of already tells us that this is probably something related to performance data, as the file name implies, of something related to image magic, which was run on Linux. And furthermore, we can actually derive the whole command line which was used to create this, and that's perf record -e Intel PT, which is the name of the CPU extension actually used to do the performance measurement. And then the command convert, which is part of image magic, which is used to either create or convert images. Font courier, which means we are going to probably write something on an image. This is useful, for example, if you do add a title to an image. Text is taken from standard input because we have a dash sign there that usually denotes standard input, and it's then written as an image PNG. So we kind of know what is happening. We got a performance measurement of this command being run when the command was basically put this text on an image and like save it as a PNG. What sort of text that might have been? Well, it was a CTF, so it's quite easy, right? It's probably the flag, or probably some text plus the flag, or a text which did tell us what exactly that was. So we spent quite a lot of time in the train to try to not solve this task, as in actually solve the task, but not really solve it by, well, trying to find the flag in this file. Perhaps these performance measurements, we didn't really know what kind of performance measurements exactly this were, and we will get to that because that's the important part of this task. So we didn't know what it is. Maybe it was like just the number of executed functions, or maybe it was like full memory dumps of random parts of something. So we started trying to either get enough memory pieces from the file to be able to recreate the bitmap inside, like from what we have here, just from the file without, dissecting it, just treating the data as bitmap. That obviously did not work. We also tried to just look for the flag if it's anywhere in the file. That obviously did not work either. And it makes a lot of sense why it didn't work, but it's always, I guess, worth trying out such shortcuts, because there are times where a shortcut will work and the shortcut would save you several hours of work. In this case, didn't work. We didn't save several hours of work, therefore we went for the long trip. So, sorry. Yeah, again, I'm recovering from the cold, so I'll be coughing quite a lot today. So now we get to how do we get what the data is? How do we start to interpret the data? And we can just use the perf command for that. And to do that, I need to connect to my virtual machine, because I have, again, in the task description, there was this information that it's a Ubuntu 16.4. So I downloaded the image, I installed it on a VM, and now I have it running on my VM, so I just need to connect to it. Let's do just that. Okay. And now I'm typing in my password. As you know, I usually mute the microphone, which means probably that this password wasn't really... It's easy to guess, but you cannot connect to this virtual machine from outside anyway, so... And it's a disposable VM, I don't care, I can just tell you a password. This is the password, yeah. Security is also about understanding the severity, I guess, of the vulnerabilities. Anyway, so if we go to here, I guess I can make the font a little bit bigger to... We will be spending some time in the console, so I want it to be readable for you as well, so please bear with me a second. Okay, here we go. Now it's better. Okay. And I guess I need to unzip it. Gunzip data. Okay, perfect. So we have this file. This file is what, 17 megabytes now, and if we run the perf command, I think perf report, we will get some information about it. Do I really need to install it? Oh, I know. It actually booted on a different kernel. So we will probably have to reboot the machine, because if we look again in this file, right, you can see that there's a specific kernel given here, 4.10.-42, like 042. And what I'm running right now, uname-a, is actually like this one. And this just won't do. So let me bring this virtual machine here. This is actually it. And let's do sudo reboot, because we will have to reboot the virtual machine to actually, yeah, advanced options. And I want to boot this particular, oops, here we go. Yeah, this particular kernel version. It isn't strictly necessary, but it helps a little with solving this task. It's one of the things in this task you actually wanted to do is you wanted to have the same version of the software, because that would mean you can better interpret the data which is in the perf file. Okay, so the VM is booting. Let's do a quick question. Why do you think CTFs are not pleasant to watch? They are not pleasant to watch because the entry level to watching it is quite complicated, and actually watching somebody try different things and think a lot without doing anything is quite boring. There is not a lot of action going on. And again, the entry level is quite high. This is something that folks can appreciate, folks which have the knowledge to do it. So for example, it's like, you know, watching a chess game, if you know the basics, might be quite interesting. If you know a little more, it's even more interesting. But it's not the case where you're like, you would have to be on grandmaster level to be able to like just wrap your head around what is going on. And that's the case on CTFs, right? You have to know a lot to be able to wrap your head around it. And there are things like there is, for example, the pony race, right? Where folks try to make it more entertaining, and it works to some extent, but I think we still have a long way to go to make it really entertaining, and we have to decrease the entry level. It is a really good question, actually. But, you know, CTF has always been something where, well, technical folks can compete against each other, and it wasn't really a sport to watch. Cool, so we can, I guess, restart this one. Here we go. Yeah, sorry. Okay, let's try it. Perf report again. Here we go, now it works. And it's processing the events. There's only 17 megs of it, and it still took a while. And yeah, as you can see, it already tells us something interesting. It tells us that there are 2000 instructions, which means we probably have instruction granularity knowledge about this, which is already great. And if we go to it, we get like typical performance measurement data, as in how long did the CPU spend inside a given function or inside a given library or whatever. Here we can see that inside the write one PNG file, we spent most of the time, which is 40%. And I guess we can even enter this and see that, yeah, like some more details about where exactly we were and how much time did it take there. Yeah, but these are like typical PNG functions. So, but this isn't really like just having the percentage of how long did we actually stay, did the CPU execute a given function. This is, well, the data here doesn't really allow us to derive any information in a simple way. There are ways sometimes to derive some information about it. For example, like think about if you would have a library which implements multiplication on really large numbers, right? And you have this kind of data, and you can supply one number to it or like two numbers to it and be able to determine and you'd like to determine more numbers which are in the equation. You could easily detect how, like, if there was a 0 in the result before the multiplication somewhere, because multiplying a number by 0, even a super large number, still gives you 0. So that would be like really low CPU usage. And on the other hand, if you'd if actually there would be a non-zero number, then it would take some more time. And how much time, based on how much time it would take, if you would make some calibration and measurement, you actually could figure out how large is the number at all. But this is not the case here. We actually need to get the flag. We are not interested in bits itself. So this is not a side channel, a crypto side channel, which was what I was talking about. But looking through it, we can see more interesting stuff. Well, we see the png.so, and we saw the typical PNG writing functions from libpng, which is one thing. We also see libmagic. We already knew that ImageMagick is going to be used here. And we also see the font libraries, which are used to render the font, right? Rendering fonts is actually quite complicated. Most of the fonts which are in vector format, there is some kind of a virtual machine implemented to execute the vector format. And look at Mateusz Jurczyk's talks from various conferences on fonts, because you can truly appreciate how complicated fonts are. So there will be probably a lot of font related stuff. And we have the font config here. We have like libpng, libz, well, libc, ld, that's quite obvious. We have the convert itself, which we knew about. And then we have lib3type, which is using like some free type open face and then T1 face in it. T1 is one of the font types, if I'm not mistaken. Then we didn't get some symbols here. I actually needed to download. So yeah, here we don't have symbols, and everywhere else we do have symbols. This is by the way kernel mode address. So I didn't download symbols for the kernel. I did download symbols for other libraries, which I did install in these specific versions on this machine. And to download like debugging symbols, you actually have to do, let's look at etc apt something sources, I think. Yeah. I think you have to add this. I don't remember. I never remember which one you have to add. But there is something you have to add, like some repository you have to add to apt. And once you do that, yeah, I thought it was actually dep-src, but it doesn't seem it's dep-src. I guess you can Google it out, and then you have to install like apt install a package name and then dbg sim, like debug symbols, and it will download the debug symbols for the given binary, which means you can like debug the binary, or any other, like for example perf, this tool which we are using, can use the symbols to display meaningful names of the functions instead of displaying addresses. Okay. Let's do the reboot. No, I don't. Let's go back here and see what else we have. Okay. So we already looked at the libraries. We have FreeType, we have libz. Libz is for deflate, for compression in PNGs, right? PNGs same as the zip archive format, or like half of the web traffic use deflate for like deflate algorithm for actual compression. And libz is one of the implementations of that algorithm. I think the most common one. Then there is GOMP, which is I think like GNU Open Multiprocessing or something like that. pthread, which is again more of a low-level system library for threading. Sorry, still recovering from the cold. XPath, I don't remember what XPath was for, in all honesty. I don't think it was important. And that's about it, I guess. So we kind of know what we are dealing with. Now, the way I showed it to you right now in form of a nice report is one way to show it, but another way is to actually do perf script. And perf script actually shows you the same stuff, but on a, let's say, on a lower level. By lower level, I mean it actually displays all the logged events inside the perf file, because the perf file doesn't have the percentage data. To get that statistics about the percentage data where the CPU spent most time in, perf report needs actually to analyze that data and to aggregate it, which means we have individual events. And for example, an event might be a branch event. Branch meaning the CPU was executing code and then it branched. It stopped executing the like linear code flow and it jumped somewhere. Or like it returned because it was a return, but the return again is just a jump, right? Or like it called a function, but calling a function again is just a jump, it's branching. So in this file, we actually have the branches, right? And for, this is in kernel mode, but if we scroll down a little bit here, let's scroll even further actually, because this is symbol resolution, we don't care. Yeah, let's jump, you know what, to PNG something. Yeah, wait, that was a mistake. PNG something. Okay, it's thinking. This file, on the other hand, like the text version of 17 megabytes, has actually 8 gigabytes, which means it's a little bit, might be a little bit slower, the seek and the searching. So let's maybe break it. And I'm actually going, I do have this file downloaded, like the output of this perf script command. I do have it downloaded on an SSD drive on my real machine. So I guess we are not going to be using the VM too much anymore. Let me show you the file. I do hope I still have it. Oh, here we are. It's perfect. I'm not going to open it in Sublime. I'm just going to use the lister from Total Commander. And I'm going to look for PNG without regex. PNG something. And it's searching. You can probably see the percentages here. I guess like writing the PNG is going to be at the very bottom of the file, so it will take a couple of seconds. Yeah, here we go. For example, if we can read from here that when we were running this concatenate magic string function from libmagic core, then there was a branch. This is a branch event. The branch happened on this address and it jumped to this address, and then it happened on some other address, blah blah blah, and then in the end it jumped from this and it called the register PNG image, and then the register PNG image actually jumped into PNG get header, and this is at PLT, which means it invokes symbol resolution, because Linux by default does the lazy symbol resolution, which means that as you can see here, it starts resolving the, like looking for the function in the library to basically import it, as in actually find its address, because that's what importing is all about when the library is already in memory. So yeah, this is what we basically have. We have a set of events, like 8 gigabytes of events of branches. Like, we know what code was executed. We know exactly what code was executed, because if you think about it, right, you know that if there was no branch, that means that the CPU just went going. And then when there was a branch event, we know where from and we know where to. So we know every instruction which was executed during the invocation of this convert command. Now, the problem is we know which instructions were executed, but we do not have the data. We do not know what was the registry state, what were the parameters or arguments which were passed to functions which were called, and we have no memory dumps. We don't know what's the state. We don't have anything. We have only the code which was executed, which makes it a little bit trickier. How do we actually get the flag knowing what code was executed, but not on what data was it executed on? So yeah, the first idea we had was actually to look on. So I guess like KD quickly came with an idea to figure out how large is the image, as in how high is actually the image, by looking for PNG right row, or was it row right? One of these functions in any case. Yeah, it's here, but this is again the resolution. If you look how many times this address was actually called, and we can look for that. So that's like once, twice, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, and so on and so on. You can actually figure out how high was the bitmap. And then we started thinking about maybe we can trace the deflate algorithm. How was it compressing the data? Because based on that, you might be able to derive what data was actually compressed. Because you know how, we know how deflate works. We know that it works like there's two algorithms actually applied. One is the Huffman tree compression, and the other is one of the LZ family compressions, which means it's basically like a sliding window algorithm, which sometimes instead of outputting data refers to data which was outputted in the past already. And that's one idea, but it's kind of tricky if you start to think about it, because we probably might be able to distinguish between like, let's say, different type of data. We don't really need the colors, right? We just need the, even if we get the edges of the letters, that's fine for us. But it's kind of tricky, and PNG, on top of actually using deflate, it also uses a set of filters which make the data better compressible, which means they decrease the entropy, which means the edges might be not really readable to readable, because they might decrease the entropy, and it might get even trickier. So yeah, we thought about doing something else. And to do that, I started basically reading or looking into how does the font library work? How does the free type library, which was used here, obviously, how did it work? And let's just look into it. Free type example. And we have a free type tutorial, and we have a free type example. So let's look in free type example. This is like a simple example of which, if we go to here, actually takes an argument, the name of a font, and we know the font was Courier, right? That's not how you write it. Yeah, that's how you write it. And then the sample text, and it actually generates an image out of that by rendering the sample text using the font which we passed to it, and outputted it to a bitmap. So this is what the example does. And if you start reading what it actually does, it like initializes the library, which says here, then opens basically the font file, and then like sets the size, and then there's something, and then there's load character. Now, one thing I actually know about fonts, and it's quite obvious, but I know it because I chat a lot with Yuru, and again, Yuru is an expert on fonts. So, but it's quite obvious, is that not every font actually has every character, and that's quite obvious if you ever tried like writing whatever different language than Latin or like English with like special characters, be it Chinese, be it Japanese, be it Polish, or whatever else, right? You will quickly notice that not all characters are there. And even if you try some like smiley face, like emoticons from Unicode, you will notice that not all fonts actually support them. What that means is that a font isn't really a table of glyphs, of letters. It's more actually of a linked list. But then you need to somehow map like know which Unicode corresponds to which font. If it would be a table, then like you take the code and you look at this index from this code. If the code is like 10, well, 20, let's say 65 for the capital A letter, then you look at index 65, right, of the font table. But that's not really the case for fonts because, well, there might be some characters missing, so the indexes stop actually working out. So you do need some way to map the character to the glyph number, the glyph index inside the font table. It's actually a table. You can think of it as a list, but it's actually a table. And there are several ways to do it. You can, well, I guess the easiest way is to either have some sort of a hash map where you put the key of the hash map is the Unicode character, and the output of the hash map is the index to the font table, to the letter table or glyph table actually. But that's one way to do it. The other way to do it is just to have the font table sorted and then do binary search. And binary search is actually quite fast. As you probably know, is I'm not sure like if everyone is familiar with binary search, so let's just do a quick example of that. If we have some, like, let's say we have, this is a sorted array, and if we want to find out whether, for example, 65 is inside here and where exactly is it, which exactly element is it, binary search works like this, but you start with, let's call it the left side and the right side. I'm actually doing it vertically, but it usually would be presented like this. So this is the left side and this is the right side. I'm just going to call it the left side and this is the right side. And then you take the middle element from them, which is I guess 20 in this case, and you compare, is 20 this element? Well, it's not. Is it larger than this element? Well, it's not. It's actually smaller than this element, which means if it's smaller, you actually grab the left one, the top one limit, and you move it to this element, which means you basically disregard of these. And this was one step. Then now your left element is on 20, so you take the middle argument. Well, the middle argument is, let's say it's 25, because that's how our algorithm would work. And 25 is actually also smaller, which means, again, you move the left delimiter, or the top one, here, and this was your second step, by the way, and then you look here, and here you actually, like, again, take the middle one, 70. 70 is actually larger, so what you would normally do is you would move this one, the right limit, to here, but we are actually running out of elements, which means we need to stop, but this was the first step. If 65 would be here, it would be somewhere in this range. So in any case, we only made 3 steps and we looked through like, 7 elements. And usually this means that the complexity of it is like capital O of log n, which means that for like 1000 elements, we would only need 10 steps to determine if a number is in this table, or if, so that's one thing, and the other thing is which element of the table is actually that number, if it exists in that table. And This is, by the way, you might recall this algorithm being used in web security in blind SQL injection, because this is commonly what you do. You can answer a blind SQL question whether something is true or false, and you start asking questions like, hey, is this number like the first letter of the password, the ASCII character code actually of that first letter, is it larger than 65? Oh, then is it smaller than 72, and so on and so on, and you basically like start decreasing from both sides of the paddles, and you do a binary search until you reach which exact letter is that. And one of the variations of a CTF task, a reverse of a blind SQL injection CTF task, is actually to look at Apache logs, like HTTP server logs, from a blind SQL injection attack, where somebody did this binary search to determine what was in the database, and the task in that case would be to determine what data was leaked, and the flag would be among that data. And what we would have to do here is the same thing. This isn't the logs from Apache from blind SQL injection attack, but perhaps the font implementation actually uses binary search to determine which character maps to, which character code maps to which glyph inside the font, which, you know, the graph, vector rendering of a letter, right, the glyph. And if so, then based on what exactly was executed, how this binary search algorithm was executed, or if not, it's not a binary search, if it's like some hashing algorithm, how that was executed, based on that, perhaps we can determine which exact character, which exact glyph was found and taken from the table to be rendered on the bitmap. And based on that, we can, well, do the opposite, like knowing the glyph, we can like lead it to the character code, and knowing the character code, we can get the flag. So that was the idea. What we were missing is basically to figure out, okay, so how does this actually looking for a character glyph, how does it look like? Is it binary search, or is it like some hash map, or is it some other algorithm, right? But okay, let's go here and let's look at the documentation of FreeType. If we go into the documentation, actually not here, well, maybe here, I need API reference. Because what you basically need to learn about a given library. How does it work? So I spent like 5 minutes reading through this page. Sorry. And I quite quickly stumbled upon this. Get character index. And if we look at it, and it actually has a character code and it gets the index, and I'm wondering if there was also a get glyph index, or is this, yeah, no, there's glyph name. So okay, so this is char map, not bad. Yeah, this function is probably returns the glyph index of a given character code. This is exactly what I said. It takes a character code and it returns which font, which vector rendering of a letter actually to render. So let's see if in our log, our 8 GB log, we can actually find a call to this function. So let's look for it. And as you can see, it is here, and obviously at the first ever call to this function, we fall into the PLT, which is the dynamic symbol resolution, so we do not care about that. We jump, until we actually get here, which is after the symbol has been resolved, it actually the function gets executed. And as you can see, this function goes here, and this branches into another function which is called T1 CMap Unicode char index, because FreeType you can support multiple font formats, and there are a lot of font formats. So I guess like T1 is being used here, and then we have this jumps into PS Unicode's char index, which gets executed for a long time. And if you just look at the addresses here, and you kinda know what to expect, you can say that these addresses look like a loop, like because like for example 5BE, sorry, B5E is here, is here, is here, is here. That's a loop, and then it's here. But for example, the pattern is kind of broken because we used 4D to 7, 4D to 7, 4D to 7, 4D, 4D. So this is the pattern was already broken. To 7 should be here. You know this is some kind of searching. You don't know what kind of searching is it, but it's some kind of searching. So great, we know the name of a function which actually does the searching, and as you can see, it then goes back to get char index, so it basically returns to the main function. So we know this is the function we should focus on. And if we look for other like functions of the same name, other invocations of ft-get char index, you will notice that there's quite a lot of them in the file. So probably quite a lot of letters were written, or actually in font rendering, you might call this function not only for rendering a font, but also to determine what is the size of a glyph you want to render. Because that's quite important when you start, you want to render a word, right? You actually need to know if a word will fit into your bitmap. Maybe you will have to actually do a word wrap, like wrap the part of a word somewhere else. And to do that, you need to know what is the size of a glyph after rendering in pixels, for example, or subpixels. And you might want to call it some more times even before rendering the font. But it's called multiple times, and it looks each time different, which actually gives us a lot of hope that this is actually doable like this. So what we need to do is we basically need to look at the source code of this. So this and GitHub, and let's see if there's maybe not this one, maybe this one. Is it here? Oh, this is the changelog of free type. What I actually need is the free type. Yeah, sounds good. Like whatever repository, we don't really care too much which repository is it. And we want to search in this repository. Yeah, here we go. This is the implementation. And perform a binary search on the table. Yes, this is exactly what we hoped for, what we are looking for. So we know that this is a loop. There is the min and max, or left and right, however you want to call it, or top and bottom. This is the boundary, and then based on whether it's like larger or smaller, then you either move the left one or the right one to the middle one. And do this until you find the proper one, or until you determine that this glyph is actually not inside the base of our glyphs. Now, there are two ways to actually go from here to solve this task. One way is to determine basically what is the glyph table inside the courier font which was used. And so that's one thing. And by the way, which exactly courier font file was used? And this is where in the description, as you might remember, if you look here at the refrain, there is this LaTeX thing here, right? And this actually tells us that the font, the courier font, was taken from a LaTeX set. So if we, I think I have it in the history somewhere. Let me take a quick look. Yeah, I actually have the name of the font here, which was in the TextLive fonts package, and this is actually the courier font file. So it's actually quite easy to determine. So I'm going to skip it. I guess I like kind of googled like what's the name of a courier, where can I find the courier font inside for Ubuntu, what package do I need to install, and they said yeah, install this, and then using some it's like there was like a font list which I like FC list, yeah, FC list. Basically, if we do grep courier, it will tell us that the regular courier is actually this one. So yeah, FC list is like font config list. It lists all the fonts you have installed in the operating system, your like Linux based operating system, as a typical one at least. So yeah, you get the glyph table from that file, so you kind of need to understand how to get it. And then based on these addresses, oh, sorry, I think I scrolled. Yeah, based on these addresses here, you basically need to take the binary and the source code and try to determine which branch is which when the compiler starts optimizing things isn't really super pleasant, but it's doable. The function is quite short, as we saw. And you determine which decisions were made, and therefore you can determine which, what glyph was selected. And this is the proper way to do it, which means we didn't do it this way, because on CTFs, you know, time is of the essence, and you basically want to do stuff fast, not always the proper way. So the way I decided to do it is I decided to basically do the same thing they did, as in make a trace log, because this performance log is basically a trace log, so tracing the execution and making a log out of it, right? A trace log. And I decided to make a trace log of executing the example code for each and every character in the ASCII table. Just one character per execution. So I would create like 96 or how many printable characters are there in the ASCII table. A trace log for each of them, and then bring both this trace log and my trace log, which would be in different format because I would be using different tools, to basically represent in like a common format, and then just compare both of them and match based on that. I know there is ASLR, which randomizes the top of the addresses, like this part. This part would be random with each execution, but I don't care, because the function is quite short, and these addresses never change. Like the bottom 12 bits are never randomized, because ASLR actually, for libraries, it works on a page granularity, and page is 4 kilobytes, and 4 kilobytes is actually like in hexadecimal, that's 1000, which means that this is always like a page always starts at 0 and always ends at something, which means that these addresses, the 3 nibbles, the 3 hex digits, are actually always the same, regardless of the top addresses. So ignore the top addresses and we'll focus on the bottom addresses for now. So how would you do the tracing? There is a proper way to do tracing, and there is the thing I did. What you could actually do is you could execute the perf command on the example code, and you get basically the identical output. And you can use it almost without any modifications, without some simple string parsing. Sadly, I run it on a virtual machine, and the virtual machine does not have the Intel PT mechanism in the CPU, which, as you might remember, was actually used to create this performance file. So this is the Intel PT thing, right? I do not have it on a virtual machine. I cannot use perf. Too bad. If I would have a Ubuntu 16.4 machine with this exact kernel, with the exact libraries on a real CPU which would support this, then I would do it there, but I didn't have it, so I opted into doing actually a GDB, using GDB to do a trace. Now, bear with me a moment, because I think I need to find yeah, I need to find my files for this. Okay, here we go. So this is IDA Pro with color-coded branches. So if we actually jump into the graph view, this is the function we are looking at. And I color-coded the branches, so in this view I actually can see that this is one, nodes. I color-coded the nodes. This is one node, this is the other node, this is the third node, and so on. Because if we look at the trace log, then like the perf output, right? What you can see is, for example, when we start the function, we jump into here, we jump into AF0, this matches, and then the next branch event is from B18, and B18 is actually here. So if we would look at it like this, it's not obvious, like we are going here, but it's not obvious where we went next. But if in the linear view, because this is how it should be looked at, in the linear view it's quite easy, but if we started here and we went until B18, and on B18 we made a branch event, then we had to execute this node, and this node, so these 3 nodes. So what I did is I basically created a GDB script, which I should be able to show you. It's, oh, this is not the GDB script. Because I have it on the server probably. Yeah, so let's go to CTF and yeah. So I created a GDB script which basically created a breakpoint on each and every beginning of a block. So AF0 is actually, I don't have it on AF0 because I don't care, but I have on B07, then B15, that's the next block, then B20, I guess, B20 is here, and so forth and so on. There are not a lot of blocks in this function. This function is quite small, this is why I went for this method, because there are not a lot of blocks in this function. So I created a break everywhere, then I told GDB, hey, basically display on like every breakpoint, always display the address where you broke. Then I also added like another breakpoint and commands which are to be executed. So if you in GDB do break and something, it doesn't have to be an address, it can be a function or a line or whatever. And when you type commands, these commands are executed when the breakpoint hits, and you end it with end. So when this breakpoint would hit, it would quit, like GDB would quit. And this is B69. If you look here, it's actually the exit of a function. There are 3 exits, 3 places where we have return. And yeah, B69 is actually one of these returns. So if we reach this return, or this return, we actually don't need to execute further, just quit GDB. And then yeah, while one continue. So I just started it, and so yeah, I started it here. This is the font, this is the letter, and the letter was actually, the file letter was first letter A, then letter B, then letter C, and so forth and so on. And then I broke on the beginning of a function. This is why I do not have a AF0 here anywhere. After it broke here. It's added these all additional breakpoints, and with each breakpoint being hit at some point, it would display this, and then it executed continue until one of the end breakpoints would be hit. So this basically is a super simple way to trace it. I know you can probably do it in a simpler way in GDB, but I didn't want to grab through manual too much, and this was quite fast for me to actually make. And on top of that, there was a Python script, which I think was this one, which, yeah, for every printable character in the ASCII range, starting from a space and ending with a tilde, with, you know, this sign, create the letter file and write the letter there, like a character of this letter, and then execute GDB batch this script, which I just showed you, and like output it nowhere, and output the output to passed through grep, passed through AWK. AWK is like for, it's a pretty useful tool for string manipulation, basically. So it selects the second column, because by default it actually like cuts the string by spaces and selects that second column, and it outputted it to whatever was the character code. So I got a set of traces this way. So let's look at the trace for letter A, for example. Oh, sorry, was it? It was hexadecimal, so letter A would be 41, of course. And this is the trace which I got. But again, this is the trace of nodes, it's not trace of branch events. So what I had to do next is I basically had to convert either this to the branch format or the branch format into this, and I decided to do the latter. To do that, I used a not too smart way to do it, but again, I basically do not care about anything which is before the 3 last letters. So I only care about the B07, for example, here, right? And I have a list of all the nodes. I have a list of translations. So the translations, I took the branch event, like for example, from A if a branch event started on AF0, so this is basically the previous branch event target, right? This is, if we look here, this would be this, AF0, and then B18 would be the place where the next event took place. So AF0, B18, and I would translate this. I would not enter this B18 into the list of things which are executed. AF0 would be entered, but B18 would be not. Instead, this which is on the list would be entered, which is B07 and B15, because again, as we looked on this, if we start from this and execute until B18, that means that B07 and B15, these two nodes starting at these locations, had to be executed. And yeah, so I made this manually. Well, you can see there are 10 entries. It didn't take me more than 10 minutes to make it. And then I did some, this is like regular expression string processing. And I basically started to, this is the mapping, which is again, going through all these files, like 8 GB file. It is looking for calls to this function, and then it tries to create a list of nodes which are being executed here, so that I have a map of per character trace executions in this format of the node list which were executed, nodes and the order in which they were executed, for each character that was generated by my GDB script. So if we go to out, this is here, all the characters and all the traces, which I showed you before. And I'm getting for each, basically like a block of text like this, I'm getting all these addresses translated again into the same format. And once I have this done, I basically start comparing. Like I have a list, like from this, I have a list of traces, and now I compare it to, is it a space? Is it like character code 21, character code 22? Do the traces match 1-to-1? Like all the blocks were executed in exactly same order. If yes, then I have a match and I can output it. And I output it somewhere here. Where is it? Yeah. And that's it. This is all the code does. There is nothing else there. So if we run it, and I guess we can run it. Do I have, yeah, I have it here. So let's Python go. And it's 8 GB to process, so it will take a moment. So let's see if there are any questions. I'm waiting for a stream about VMX and APIC machine check architectures, so anything about this topic in upcoming streams. I don't think so. At least I don't have anything planned about VMX or APIC or machine check architectures. Yeah, sorry. I'm pretty sure I have like VMX somewhere on my list. Or do I? Yeah, I am. That's a little bit beyond what I usually do on my streams, sorry. Okay, it actually stopped. So what you can see here is that it goes like through the alphabet, then there is like something, which I have no idea what is it, and then there is some more thing, and then at some point this starts to appear. Lag and something, lag and something. Lag, that kinda sounds like flag, but what happened to the F? And if we actually look around, we will notice that for some reason the F is rendered at the end. So that's fine. That's actually like flag, and this is the flag, and this was actually the flag. So yeah, using this method, we actually got the flag and were able to solve this challenge. I don't remember as which team, I think the third team that solved it or something like that. So that was quite cool. So I really liked this task because it was atypical, it was quite unique. It was, again, log analysis, but on with an idea which I didn't see before yet. And you were trying to basically get what data was being processed without having the data be actually in the log. You only had the calls which were made. And in the end, you still could get what fonts were actually used, what fonts were, well, not really fonts, what characters were actually processed and what characters were actually put into the file. So yeah, I really liked the challenge. It was well made and quite unique, and I was super happy to solve it in the end as well, because it wasn't super trivial, but it wasn't hard either. So yeah, a fun challenge. Okay, I guess let's if you wish, I can upload my scripts and everything to my GitHub, but for today I don't have any other topic actually, so let's go with the questions. I know there are quite a lot of questions on the... Yeah, there are quite a lot of questions, so let's go through them. And I'm trying to figure out what should we do next week, but Foxtrot is actually asking, should we do a HTB, like hack this box? Maybe we should. I don't know. I still need to decide on that, and still need to decide how much time I actually have to prepare. But yeah, we'll see. Let's go with the questions for now. Is it really possible to extract password by just the sound of typing it? Yes, basically yes. That's the answer. But there are several things you have to take into account. And actually, if you go to my... Oh wait, I don't think... Okay, I'm not sure if I actually have this on my blog. I think I have this on my blog. I don't have like the research about it on my blog. I have the links to the research. So if you go to my blog, sorry, then yeah, from... No, this is from Codive. I don't think I have it, the presentation I was thinking about, on my blog yet. How did that happen? Maybe it's on Synfo Ginveil. I wonder if my presentation was already published somewhere. Well, whatever. I did give you a link to it a week ago or something. I'm going to give you a link again. Just give me a sec to find it. I need to... I forgot to totally publish my slides on the blog. It's from a presentation. Yeah, just like transcribe this. But no, I'm just going to give it to you on the chats. Here you go. And yeah, if you go to slide number, where are we? I guess if you start with the sound of keyboard, like slide number 74, there are links to various research in the topic of can you actually get what was typed on a keyboard based on the sound, based on the timings, or based on like some other stuff like the fluctuations in the power grid. The answer is yes, if you have basically like kind of laboratory conditions, or can filter out stuff properly and have a good model or of either the person or the keyboard or both of them. So yeah, it's not like it's easy. It's totally not easy, and furthermore, I don't know if that had been ever used in the wild, but it has been proven that it actually is doable. So there's, yeah, you know, these distinctions of actually something being easy to do and easy to exploit, and this isn't. Yeah, so I guess that's the same question. And again, in that presentation, there are links to proper research done by other folks on that. Why did I say the password is easy to guess? In Polish, it's super easy to guess. It's like literally the first thing you learn to read in Polish is Ala ma kota, which is Alice has a cat. And like it's in, you know, the books for which children at the beginning of primary school get. Is like literally the first thing you read. So it's a common phrase in Polish. If you're not Polish, then it might be a bit harder, but yeah. Pwn to Own 2019 was awesome. Any comment about it? I didn't look at the results yet. Thank you for reminding me about that, because I didn't look at the results. I'm quite curious, actually. Do you use Mac at work and privately? No, I tried to. I had like 2 attempts to actually use Mac for work or privately, but in the end, it's not my thing. I don't have a taste for it. I'm too used to, I guess, Windows. Because I've been using Windows most of my life. I've been using DOS before that. Not Linux, but DOS. And I'm pretty used to Linux on the servers. Linux is what I'm using on my servers. But for desktop environment, I'm just too used to using Windows. I know a lot of people like Macs. In what program do you draw on the screen? That would be Zoom It. Zoom It from Microsoft. You can download it on Microsoft's website. That being said, well, it's originally from sysinternals, actually. I'm not sure I understand the question or comment. That work with Feedline, I'm not really sure about that. Did you hear anything about Commando VM? Actually, no. I have no idea what that is. Sorry. Yeah, I still do not. Yeah, sorry, I'm out of context for a Feedline question. I'm sorry. Is it possible to have a symbolic analysis-based tool to deduce data from a trace? Good question. I guess so. But why symbolic analysis? I'm wondering how you would use symbolic analysis in this, actually. I'm wondering if it would be... Because, like, for example, for the idea with the decompression, right? You might not really be able to derive the data from the decompression trace log. You might be able to derive the, like, how's it called? Like the connections between parts of data, which means you do not know the data, but you know that, for example, this plus something, or like this character was repeated 8 times and the next character was repeated 3 times, but you do not know which character that was. And that might be fine. I'm not sure how symbolic analysis would help here, though. I might be missing something. Silence on the Wire is a bit on the subject. Silence on the Wire is one of my favorite books. It's by El Kamtav, by Michał Zalewski, whom I worked with for several years. Well, I worked on his team. And I really liked the book. I always liked it. So if you didn't read Silence on the Wire, I totally recommend it. And yeah, it's a bit on the subject. There are several chapters which are on side channel attacks. There is the Blinken Lights side channel attack described, which is really fun to read about. What are your thoughts about AI airship? What's AI airship? Let's look for AI airship. I have no idea what's an AI airship though. Airship AI. I guess I do not have a comment because I do not know what that is. I'm sorry. Do you remember Gunveil's alphabet? No. I mean, I remember what it was. Basically, the idea was that somebody would ask me a letter and I would have to figure out some security-related phrase or word or like term relate on that letter. Like, for example, you know, H for hackers or whatever. But okay, that was a triple one. But and we did try that on several streams where somebody, usually guest I guess, would have a question about that. But we didn't practice it for a long time, so I don't even remember which letter we finished on. That was pretty fun though. Can we have an Android hooking livestream? No, because I have no idea at all about Android to the extent where when I'm solving Android challenges on CTFs, I'm basically rewriting the code to run on x86. That's how bad I am with Android. So yeah, I just don't have any idea, I'm sorry. Do you think kernel mode anti-cheats are serious security vulnerabilities? I mean, cheaters who try to bypass it may abuse finding versus normalizer. So it's a good question. I mean, if you create an anti-cheat in a proper way, it's not going to be a vulnerability. If you do not create it in a proper way, then it will be a vulnerability, but that's true for everything, not really anti-cheats. What I'm wondering about is whether it's worth it, as in kernel mode stuff, especially stuff like anti-cheats, is quite intrusive into the operating system, and that might destabilize your system. For example, your system works now, and then Microsoft changes something, a new patch comes out, and it turns out that the anti-cheat actually crashes your Windows. That's pretty likely scenario, actually. So I'm not sure if it's worth it, because in the end, anti-cheats which are running on a machine fully controlled by whoever wants to cheat will lose the battle. They might be one step ahead, but in the end, the result is always the same. The result is that they can be disabled because the user has full control of that machine. So I'm not sure if pushing to kernel mode is a good way to actually solve that problem. There might be different solutions. Yeah, like for example, like OnLive or Google Stadia are one of the solutions for cheating, right? If the game doesn't run on your computer, it runs on some server, then unless you pawn the server, you cannot install a cheat, which is a good thing. That being said, while like Google Stadia works really well, there's still a level of difference between running something locally, especially in like pro gaming competitive level. I'm not saying for like casual gaming. For casual gaming, it's great. But I'm not sure I would like to play Counter-Strike on it, where I'm, used to 160 FPS. But any other game, yeah, sure. Especially that I'm sure that cheats are harder to make for stuff like that. Livestream for my Windows plus Linux setup in English next time. That's a request. Yeah, I guess we might want to do it. Because, why not? I mean, I did it in Polish. It was quite a lot of people are actually asking still about it. So we might do it at some point. I'm not sure if next week, but maybe soon. Or maybe I should write down like how to set it up properly once and for all, instead of doing a live stream about it. Because the live stream in the end, after a couple of years, new software, new things you have to worry about, it will just be old again. So I'll think about it. That's a cool idea though. Okay, and I guess that's it. So thank you very much for today, and thank you for being here. Thank you to KrzaQ for being my moderator. And if you speak Polish, see you tomorrow. There should be a live stream tomorrow. If you speak English, then see you next week. And I'll still have to figure out what will be the topic for that. That's it. Have a happy evening or happy rest of the day, depending on what time is it at your place. And happy hacking. See you next week. I'm going to leave you with some music. So yeah, see you next time.